While surface area and volume appears to be quite an easy topic to master and really score well, there is still some confusion in some of the students when to use curved surface area and when to use total surface area. So that is something which we'll try to clarify in this particular video, where in most of the questions, like in this question as well, it is not mentioned whether you have to calculate the curved surface area or the total surface area. It will just be mentioned as surface area, and we have to figure out as to what is the expectation from the question. Okay, now let's look at the question here. A wooden toy is made in the shape of a cone mounted on a hemisphere. The diameter of the base of the cone is equal to the diameter of the hemisphere. Okay, so we have a cone on top of the hemisphere, and the diameter of the hemisphere and the diameter of the cone are the same. So let's just draw this diagram and then let's continue reading the remainder of the question. Okay, I've got the diagram here. Okay, now what is the question now? The height of the cone is equal to the radius of the hemisphere. So the height of the cone is equal to the radius of the hemisphere. Find the surface area of the toy given that the radius of the hemisphere is 7 centimeters. So the radius is 7 centimeters. All right. So now we need to find the surface area of the toy. Now when we look at the surface area of the toy, what we have here is this particular figure. Now we have this hemisphere at the bottom and cone at the top. So the surface area would be this circular part of the cone and the bottom part of the hemisphere. We will not be having the bottom part of the cone, that area, the pi r square, the circular part below the cone, as well as the circular part on top of the hemisphere. We will not be having that. It's just the external part of this entire figure is what we are expected to calculate this area. All right, so which means we have to calculate the curved surface area of this cone and the curved surface area of this hemisphere at the bottom. Total area of the toy is equal to the curved surface area of the cone plus the curved surface area of the hemisphere. Now the curved surface area of the cone can be calculated using the formula pi r L. And now what is L? How do we find L? So if you look at this L here, how do we calculate L? We use the Pythagoras theorem here. We have the height as 7 and the radius also as 7. So 7 square plus 7 square will be L square. So L is equal to 7 square plus 7 square. 49 plus 49 is equal to 98. L square is 98. Alright, so L will be square root of 98. This can also be written as 7 root 2. 7 sevens are 49 into 2, 98. In case you're not clear about this, how we arrived at 98 root as 7 root 2, please post in the comment section. I shall create a separate tutorial on that. Alright, now that we have L, the curved surface area would be equal to pi r L. So this would then get converted to 22 by 7 into r is the radius is 7 and L is 7 root 2. So 7 and 7 cancels. So we have 22 into 7 into square root of 2. Now this is the curved surface area of the cone. Now if you have to find the CSA of the hemisphere. The CSA of a sphere is given by 4 pi r square. So of that of a hemisphere will be half of it, just 2 pi r square. So 2 into 22 by 7 into what is the radius? We know the radius is 7. So 7 into 7, 7 square. So another 7 cancels. So we have 44 into 7. All right, now we have to add these two and we would be getting the total area. So the total area is equal to 22 into 7, with 22 into 7 root 2 plus 44 into 7. So once we calculate this, root 2 is 1.414. So once we calculate this, how much would we be getting around? Square root of 2 is 1.4. So let me just take it as 1.4. To 15.6, and similarly 44 into 7 is 308. So once we add them up, 215.6 plus 308, what would that come to? Plus 1 is 2, so 523.6. All right, so that's how we calculate the surface area of this particular toy. So this was just a simple way of identifying what is the expectation from the question. Is it, are we finding the curved surface or the total surface area, or the total surface area of the top part of the toy, the curved surface area of the bottom, or the total surface area of the bottom, curved surface? To avoid this confusion, let us just try to draw a diagram and try to visualize how does it look like. So once you've drawn the diagram, we can then visualize and understand what exactly is the expectation. So my first request to all of you is, whenever you are given a question on surface area and volumes, if you draw the diagram perfectly, 95% of the problem is solved. Most of the times, the problem that the students face is sometimes they are not able to visualize what is the expectation, because of which sometimes the diagram goes for a toss and then the entire result also goes for a toss. So once we read the question step by step, and even before we complete the question, read the first part of the question, draw the diagram. Then the remainder part of the question, again draw the diagram. And wherever you have the measurements, put them right away so that you don't miss out. And once you have everything in place, then you just have to think and see what formula to be applied. Do we have to apply the volume? Do we have to apply the curved surface or the total surface? We just have three things in surface areas and volumes. We have the curved surface area, the total surface area, and the volume. Now, in this case, it was all about surface. It was all about finding the area. So we just have to figure out whether it is curved surface or the total surface. I hope you found this tutorial useful. Let's move on to let's start working on few more problems similar to this. And if you have any other questions, please do post them in the comment section. I shall create a video from that. All right, I hope you found this tutorial useful. Let's move on to the next problem statement. Have a great day. Bye.